Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Muazzam bin Azman, number matrix AA190827. Okay, I will present about simulation of lab 2 diode application, clipper and clampers. Okay, first of all we need to draw in the process similar to the circuit given in figure 2.3. The value of V source, V sine source is set 2.5. The amplitude is 2.5 as V peak to peak is 5, and divided to get the V peak value, which is 2.5. Frequency we set at 1 kHz, same as 1000 Hz. Okay, for V sine wave. Then we put we search in the library, broad library, and put a 100k ohms resistance here, and diode 1N4004, and also V source, which is voltage source, and the value of voltage we set according to instruction is 1 volt. Okay, connect and then connect all the wire to A and B before the resistor to show the input wave. Okay, this is oscilloscope. Okay, and here is my drawing, and we're gonna start run the simulation. Okay, first we see the input first. We see the input, the amplitude is 2.5, as we said, as I said, 0.5 per block, per this box. 1, 2, 3, 4, 5 divided by 0.5, 2.5. The amplitude for the input, input 0.5. Okay, you can see the input is smooth. Then we close the input. We see the output of this circuit of figure 2.3. Okay, so this is the output of figure 2.3. We see time versus time per div is 0.2 and volt per div is 0.5. I said it. Okay, then we move to the next circuit, which is figure 2.4. We must change the diode and also voltage source direction. Change the direction. The value remain the same, but only the direction different. Connect all the wire. Run the simulation. Okay, let's see the input first. Sine wave input, same like the first circuit 2.3. The amplitude is the same, and also the value of volt peak to peak also the same, and it's moving. Okay, we move to the output graph. As we can see, it is different from the figure 2.3, as we change the direction of diode and also the voltage source. Okay, this is the result. Same value of volt diff and time diff, 0.2 millisecond and 0.5 volt. Okay, stop the simulation and we move to the next circuit, figure 2.5. We change the direction of diode only, while the direction of voltage source remain the same. Okay, run this simulation. Okay, let's see the input first. The input of the circuit same, and then the output. Okay, the output is different from the previous circuits 2.3 and 2.4, which is the value or the amplitude of this wave is higher, and you can see, let's compare to the input. There are some negative value below the input wave. Okay, there's some negative value here. Okay, this is for graph for input sine wave and output sine wave of circuit 2.5. Okay, then we proceed to the circuit 2.6. Okay, the circuit 2.6, we have another additional component, which is another diode, and also another voltage source, which different value of voltage source. Okay, add the voltage source here. And yeah, diode here. Rotate. Okay, change the direction of diode 1 and also the voltage source 2. Okay, and don't forget to put grounding, terminal mode ground here, put it here. Alright. Connect all the wires. All the wires and change the value of voltage source 3 edit properties to 1.5 volt. Okay, this voltage source remain the same, its value, and also this resistance remain the same, and the sine wave voltage source remain the same. Okay, we run the simulation now. Okay, let's see the input first. Okay, the input, as we can see, same as the other circuits, which is also have the same amplitude, V peak to peak, V and V peak. Okay, and then we see the output of the circuit. Okay, the output of the circuit, there we can see the flat curve here, no sharp curve, and let's compare to the input. Okay, as we do the calculation, we can see the similarity between the simulation graph and the calculation graph. The similarity in its shape. The value may be different because I put the volt diff here different, and also time diff here different, which is 0.2 millisecond and 0.5 volts. Okay, stop the simulation. Okay, we proceed to the part 2 of this lab, which we need to draw a clamper circuit. There are several components we must add, such as capacitor. We add here. Rotate. Okay. Delete this and this. The resistance we put here. Then connect all the wires. Okay, we must change the value based on the instruction of the question. Okay, set the value of capacitor is 10 microfarad. The value of the amplitude of sine wave is 1.5, as the value of voltage peak to peak is 3, and the V peak, the voltage peak, is 1.5. The frequency remains the same, which is 1000 Hz, and the value of also rotate the direction of component here, voltage source, and also diode. Rotate, change the direction. Okay, connect the wires. Change the value of voltage source here to 0 volt, and also change the value of resistance here to 5.1 k ohms. 5.1 kilo ohm. Okay, we all set up. Let's run the simulation. Okay, we see the input first. Okay, as we can see, the input is moving and has the amplitude of 1.5, and V peak to peak is 3. Then we see let's see the output. The output is static, not moving as input, but has same amplitude and V peak to peak. Let's compare the input and the output. Okay, as we can see, the value, the graph, the sine wave is same. Input and output. Okay, so this is the sine wave of clamper circuit in part 2. Okay, that's all from me about the simulation of lab 2 about clipper and clamper. Assalamualaikum warahmatullahi wabarakatuh. And sorry for the noise background. It because my laptop having a problem because it's too old and produce some noise that will that I'm afraid will disturb the peace of the viewer. Okay, that's all. Thank you.